GCSE Physics boosters, resistance 2. This is my second video about resistance. It's a big topic. There's quite a lot we need to know about it. So here we go. First of all, if we have resistors in series, now here they are fixed resistors. They don't have to be. They could be lamps or whatever, motors, whatever. But here, what is the equivalent resistance of each combination? Okay, and I am sure that you can do these. Pause the video, work it out, pen, paper, calculator, if you need one, work it out. I will tell you the answers in 3, 2, 1. So resistors in series, you just add them together. R equals R1 plus R2 plus ... So this one, 50 plus 100, I reckon that's going to be 150 ohms. Okay, this one is 250 plus 8. That's probably, let me check on my calculator. Yep, that's 258 ohms. 300 plus 50 plus 16 is going to be 366 ohms. Okay, and then 80 plus 80 plus 20 is 180 ohms. Okay, resistors in series, you just add them together to find the resistance. Now, a little bit trickier is resistors in parallel. Here we've got a 90 ohm and a 30 ohm in parallel. You don't have to work out what the resistance is exactly, but you need to be able to say, now, multi-choice, A, B, or C. So look at those. Is it going to be 120, or is it going to be 60, or is it going to be 22.5? And the answer is, oh, look at him teasing. It's that one there. It's 22.5. At A level, there is an equation, which is a bit fiddly to work it out. What exactly do you need to know? Well, you need to know this. When you've got resistors in parallel, now the total resistance, the effective resistance, is less than the smallest resistor. So if you've got 90 and 30 ohms, I know that it's going to be less than 30 ohms. The total resistance is less than the smallest resistor. Basically, what you're doing, it's like building a bypass. There's another route for the current to take. So the current is going to be bigger. And if the current is bigger, then the resistance is smaller. Yeah. Hopefully you get the idea. Have a go at this one. We've got a 300 and a 600 in parallel. What is the resistance of this combination? And the answer is, and I'm sure you've got it, the answer is 200. Now why? Because it's got to be less than 300 from what I've just said. If it's less than 300, then the only one that's less than 300 is that 200 ohms. A couple of components that we need to know. Now, these are special types of resistor, and the first one is called a thermistor. And basically what happens is its resistance depends on its temperature. With a metal, when a metal gets hot, its resistance gets bigger. Now, this is not a metal. This is made of a semiconductor. And when it gets hot, its resistance gets less. Its resistance decreases with temperature. We say it has a negative temperature coefficient. If you look at the thermistor, you see there NTC. It's got a negative temperature coefficient. Okay, and this is a thermistor. So what a thermistor is used for? Well, look at this circuit here. Now, what you should do is pause the video and have a go at these questions yourself. And I'll show you the answers and explain it in 3, 2, 1. Okay, so here we go. At 20 degrees centigrade, the resistance of the thermistor is 60 ohms. So basically at 20 degrees centigrade, you've got a 100 ohm resistor and a 60 ohm resistor in series, yeah, at 20 degrees centigrade. Now, what is the total resistance of the circuit? Well, it'll be 160, 100 plus 60. What current will flow through the resistors? So I equals V over R. So that's going to be 10 divided by 160. So the current in the circuit will be this 0.0625 amps, which I would write as 62.5 milliamps. Then what will the voltmeter read? Well, now that we know the current through the voltmeter, we know the current through the 100 ohm resistor, then V equals IR is 0.063 times 100, which will be 6.25 volts. So at 20 degrees C, my voltmeter says 6.25 volts. Now, for the second half of the question, the temperature now increases to 30 degrees C. Ooh, the temperature's got bigger. So the resistance of the thermistor is going to be less. It's going to be 40 ohms. So basically, go through the same thing again. It's the same equations, only the numbers are a bit different. And what you'll get is that at 30 degrees centigrade, the voltmeter reads 7.1 volts. Okay, so the temperature's gone up, the voltmeter reading's gone up. This could be used as a temperature sensor. Yeah, if you calibrate it properly, the voltmeter reading increases as the temperature increases. This circuit could be used as a temperature sensor, you know, like an electric thermometer, if you like, if you calibrate it. The other thing that you should know, there's a device called a thermostat. Now, a thermostat, thermo is like thermostat. There you go. Stat means obviously static, as in not moving. Thermo means heat. You've got one of these on your central heating, and basically when it's cold, the heating turns on. When it's warm, the heating turns off. How does your central heating system know when to turn on and off? And there'll be a circuit like this with a thermistor. Okay, and then depending on the voltage here, that will turn the heating on and off. It's called a thermostat. Here's another component. This is an LDR. This is a light dependent resistor, LDR. And you need to know the symbol for it. And its resistance decreases when light intensity increases. There you go. In other words, if you shine a light on it, its resistance gets smaller. Let's look at this circuit. It's exactly the same as the last one. The only difference is that instead of the thermistor, we've got the LDR. Have a go at these yourself, and I'll show you. I'll talk about my answers in 3, 2, 1. Okay, so a torch is shone on the LDR. What will happen to the following? The resistance of the LDR will get less. It will decrease. The resistance of the circuit will decrease. It will get less. Yeah, because the resistance of the circuit is that plus that. The current in the circuit will get bigger because there's less resistance. And then the voltage across the fixed resistor, that will get bigger, because the current through it is getting bigger. What could this circuit be used for? Well, this could be some kind of a light sensor. If you were a photographer and you wanted to know the light intensity in a room, you could calibrate this circuit. It would give you a reading for light intensity. The one that's mentioned in the specification is when kind of street lights turn on and off automatically. Like when it gets dark, the street lights turn on, and there'll be some kind of a circuit involving an LDR which will sense what the light intensity is.